Hi everyone, I'm Erin East, Product Manager for our all-new HD3 oscilloscopes. I am so thrilled to talk about this exciting new technology. No matter what type of electronics you're designing or what industry you're in, we all have to measure power to some extent, whether it's characterizing every component or just measuring the output of a power supply. The combination of the 14-bit ADC and the all-new low-noise front end gives us the visibility we need to ensure accurate results from our supply. While switch-mode power supplies are the most common and efficient power supply methodology, they introduce a fair amount of noise and ripple to your signals. It's important to characterize this to ensure your device will function properly and produce an appropriate output. To be able to measure those low-level signals, you need extreme vertical accuracy. What we're looking at today is a PicoTest Power Standards board, so a nice DUT to compare against as you're designing. You can see there's a switch mode power supply on this board, and I also have a switch mode power supply that Keysight makes for demonstrations. One of the key measurements we all have to make on a power supply is the amount of ripple and noise we are seeing on the output of our supply. We're ultimately testing the quality of our voltage regulation and filtering that is supposed to reject the noise from our switching component and other interference sources. It's important to verify the noise and ripple in your design are within a tolerable amount to ensure your power supply will work properly for whatever it needs to power. Bandwidth filters and a low impedance path are critical in order to decrease the amount of noise impacting your signal, so we can set those in the channel menu. You'll notice I'm using an active probe to do this measurement. Probes are often an afterthought, but the truth is your probe is just as important as the scope. It's critical to use the appropriate probe for what you're trying to measure. For my output ripple measurements, I am using our Power Rail probe on channel 1. Power Rail probes are designed specifically for analyzing the small ripple and noise riding on top of a large signal. On channel 2, I am using a 10-to-1 probe. And we can see what a significant difference that makes with the amount of noise impacting my signal. We want to use the right probe so we have the least amount of noise added to our signal as possible. Comparing these measurements on the HD3 to what I used to see on the 3000G, we can see what a huge difference this next level of vertical accuracy makes in these measurements. On the 3000G, with the same probe and scope settings, we are seeing a significantly higher RMS value than what we're seeing on the HD3. This difference in measurements is primarily driven by the front-end noise of the oscilloscope. With the lowest front-end noise, you won't see the HD3 interfering with any of these important measurements. Now, it is also even easier to detect small frequency components that may impact your switching design with our improved FFT capability. Thanks to the deeper memory of the HD3, we also have more data to work with to build out our FFT and ensure we aren't missing any frequency content. The extreme vertical accuracy is also helpful for other common power measurements, like current drain analysis and the math involved with that. The new Fault Hunter capability is also extremely helpful for finding any glitches or crosstalk interfering with something like my clock on my power supply. Here, we can see it scanning a clock signal, and now we can see that it found a positive glitch. Now I can copy that to my trigger so that I'm only triggering on the glitch, and I can do some more work on characterizing that glitch and where it's coming from in my design. For those of us that only care to test what the output of our power supply looks like, the frequency response analyzer becomes an even more effective way to characterize it. To ensure our power supply will work correctly no matter what we are inputting, we can set up a Bode plot so we can sweep different inputs with varying amplitude and frequency, and we can analyze the behavior of the output of our supply with those different inputs. This is the only way to fully understand the control loop response and the power supply rejection ratio of our power supply. The Frequency Response Analyzer application uses the scope's built-in waveform generator to sweep the input, and then it plots the gain and phase in the form of a Bode plot. This is just another one of the many ways to characterize your power supply with the most accuracy on the all-new HD3 series. Be sure to check out our other HD3 videos and visit keysight.com/find/HD3 to learn more about how these industry-leading benefits can help you.